process of translation occurs in the cytoplasm after transcription is over. Specifically, it takes place in the ribosome, which is produced by an organelle called the nucleolus, which is found in the nucleus. tRNA is a molecule or kind of RNA that transfers the correct amino acid to the growing peptide or protein to correspond to the codon of the mRNA, and the first one is always methionine, what AUG codes for. The tRNA contains an anticodon, a kind of triplet code or the three-letter sequence of bases complementary to the codon, also a three-letter sequence on the mRNA so that the correct amino acid is brought. The first phase of translation is initiation, whereby the small subunit of the ribosome connects the 5' end of the mRNA and the start codon AUG signals the process to begin. The A site is the section of the ribosome where the new tRNA enters and its anticodon binds to the mRNA codon. At the P site, the tRNA stops after the A site holds the growing peptide chain until it's ready to exit, in which case it transfers the chain back to the A site. The tRNA then goes to the E site where the hydrogen bond between the codon of the mRNA and the anticodon of the tRNA breaks, and the tRNA can float off for reuse. This process occurs in the elongation phase of translation, and the ribosome moves along the mRNA in the 5' to 3' direction. Finally, in the termination phase, all of the amino acids needed for the protein have been coded for, and the process ends with a stop codon, UAG, UGA, or UIA, which doesn't code for any amino acid but instead signals to the ribosome that the process is over. Release factor attached to the stop codon causes the peptide chain to be released and the subunits to separate again.